Exercise 1.6. Question number 1. What is the wavelength of a photon in nanometers emitted during a transition from n equals to 5 state to n equals to 2 states in the hydrogen atom? Given quantities. RH, or Rydberg's constant, equals to 2.18 times 10 to the power of negative 18 joule. A speed of light c equals to 3 times 10 to the power of 8 meter per second. Initial energy states equals to 5. Final energy state equals to 2. And Planck's constant h equals to 6.63 times 10 to the power of negative 33 joules second. The required quantity or term is wavelength, or lambda. When an electron transits between its energy states upwardly or downwardly, to calculate the wavelength of that transit electron, we use the formula as 1 over lambda equals to RH over h times c in brackets 1 over initial energy state square minus 1 over final energy state square. From this equation, we know that Rydberg's constant RH divided by Planck's constant h times speed of light c equals to 1.097 times 10 to the power of 7 meter inverse. So when you substitute this numerical value in terms of, or instead of, RH over HC, we get 1 over lambda is equals to 1.097 times 10 to the power of 7 meter inverse in brackets 1 over 5 square minus 1 over 2 square, because the initial energy state is 5 and the final energy state is 2. 1 over lambda is equals to 1.097 times 10 to the power of negative 7 in brackets 1 over 25 minus 1 over 4. 1 over lambda is equals to 1.097 times 10 to the power of 7 in bracket 4 minus 25 divided by 100 as a whole. And 1 over lambda is equals to 1.097 times 10 to the power of 7 in bracket negative 21 divided by 100, because 4 minus 25 is equals to negative 21. And 1 over lambda is equals to negative 23.037 times 10 to the power of 7 meter inverse. In this case, the numerical value or the equation becomes negative, since we find the wavelength, or simply length, and since wavelength can't be negative, we remove the negative sign from here, and it becomes 1 over lambda is equals to 2.3037 times 10 to the power of 8 meter inverse when it is written scientifically. And since the question says calculate or what is the wavelength, and the equation says 1 over lambda, we should have to reciprocate this equation as lambda is equals to 1 over 2.3037 times 10 to the power of 8 meter inverse. When 2.3037 times 10 to the power of 8 meter inverse reciprocal or becomes 1 over this number, it equals to 0.434 times 10 to the power of negative 8 meter. Meter inverse becomes meter. And lambda is equals to 4.34 times 10 to the power of negative 9 meter when it's written or expressed scientifically or in scientific notation. And since the question says express the wavelengths in terms of nanometer, from the value of lambda, which is equals to 4.34 times 10 to the power of negative 9 meter. The prefix 10 to the power of negative 9 indicates or expressed as nano. And finally, lambda is equals to 4.34 nanometer. Question number 2. Calculate the frequency of the green light arising from the electron moving from n is equals to 4 to n is equals to in the visual spectrum of the hydrogen atom. For this question also, the given quantities or constants are Rydberg's constant 2.18 times 10 to the power of negative 18 joule, Planck's constant H 6.63 times 10 to the power of negative 34 joule second, initial energy state 4, and final energy states equals to 2. The required is frequency. And also in this question, when an electron transits between its energy status, it has its own frequency. To calculate the frequency of an electron or the emitted light when it transits between two energy status, frequency equals to RH over H in bracket 1 over initial energy state square minus 1 over final energy state square. And frequency is equals to 0.33 times 10 to the power of 16 in bracket 1 over 16 minus 1 over 4. How? The term RH or Rydberg's constant over H becomes 0.33 times 10 to the power of 16, and since the initial energy state is 4, when it is squared it becomes 16, and the square of the final energy state 2 equals to 4. Frequency is equals to 3.3 times 10 to the power of 50. This number is a scientific notation of the above number 0.33 times 10 to the power of 16 in bracket 1 over 16 minus 1 over 4. When he evaluates or when he simplify the term in the bracket 1 over 16 minus 1 over 4, and the common denominator or the denominator is least common, the GCF is, or least common multiple is 16, and when it's simplified it becomes equals to 3.3 times 10 to the power of 15 into 0.1875. The number in bracket 0.1875 comes from 1 over 16 minus 1 over 40, which is equals to, which means that the least common multiple is 16 for the terms in the bracket. 16 divided by 16, which is equals to 1. So 1 times 4 is equals to 4 minus 1. Then 3 over 16, which is 3 over 60 becomes 0.1375. And when we multiplied the terms 3.3 and 0.1875, which is equivalent to, or frequency equals to 0.61875 times 10 to the power of 15. When this number is expressed or right scientifically, frequency is equals to 6.1875 times 10 to the power of 14 second inverse, or frequency is equals to 6.1875 times 10 to the power of 14 hertz.